Hello everyone, I'm MYAT MOE and I'm a student currently studying in BSc Honours Program, which is jointly opened by Edinburgh University and MYAT University. The title of the project is Comparison of Hate Speech and Offensive Language Detection using Support Pattern Matching, Decision Tree, and Logistic Regression models. The main purpose of this project is to prevent hate speech and offensive language, which can make negative effect not only the individuals but also the people who use the social media. Most of them are found depending on sexual orientation, ethnicity, skin color, and so on. And the worst thing is that it can lead to physical conflicts and suicide cases. So it's very important to prevent the hate speech and offensive language. And by this research, we will describe how each model work for hate speech and offensive language detection and the performance of each model. The hate speech and offensive language detection is like a classification of works included in tests and sentences, and it returns the result that it is like hate speech or offensive language or neither hate speech nor offensive language. The data set which is used for this research is taken from Kage, and it is about the collection of tweets written in English and from the Twitter. So, and most of them include homophobic and racist, and the start of the process are data collection, data loading, data cleaning, data splitting, feature extraction, training models, and evaluation. For the first method, support pattern matching, it is used linear classification, which means that it uses a linear hyperplane to split the data into different groups. Example, if you look this picture, if we classify one data, we can decide by looking at the hyperplane, and if the data is in the category B, we can decide at group B, or we can decide if it is in category A, we can decide as group A, like that. So for the second method, decision tree, it is tree-based model. So it includes nodes and branches. Each node represents the single attribute, and each branch represents the output of the test. For this research, entropy is used for the parameter criterion, and best is used for parameter splitter, which means that decision tree model defines the best P chart and use it to split the data into different classes, and it repeats the process until the tree branch is end, or the condition is end. And we can see the example in this photo. And the logistic regression is used to estimate probability of binary input by using logistic function. It is decide the result based on the two categories, and moreover, the range of the logistic regression must be only 0 and 1. For example, the data is over 0.5, it can be decided at one group, and if the data is lower than the 0.5, it can be decided as another group, like that. And for the result and evaluation, we can see a result for both cross-validation and testing data. Cross-validation is used to get more accurate and strong data by using three models, and all the results are shown with the metrics to show the performance, namely accuracy, precision, record, and advanced score. And the graph version is also shown in below. And for the real-time testing, if we import the standards like that, the three models will be returned as which is hate speech or offensive language, or neither of hate speech nor offensive language. Moreover, it makes the output overall level. It includes about the overall percentage of hate speech or offensive language, like that. So sensitive words are also shown for each model. For SPN, sensitive words are like that. So we can see that it really shows the works which should definitely be offensive language. So it can tell us a really good model, and it really has good performance. And for the decision tree, it only shows one word, but it is really like offensive language, but it only shows one word, no other included. And for the logistic regression, it lists that all the words which should definitely be offensive language, but it also showed that the normal words which is used for normal conversation. So compared with the support machine, it is really good, but not like it's not better than support machine. So based on the result, we can see that support machine is the best performance, and then the second will be logistic regression, and the third is decision tree model. So as a conclusion, the future researcher will be able to study about how each model works for his speech and offensive language detection, the performance of each model for like how they good or how they accurate. So that's all. Thanks for listening. Thank you.